Here are the probabilities we calculated in the last video. If you need to, you might want to pause the video and write them down if you didn't write them down as we were going through them in the last video. Then here they are in a probability distribution. And I've also given the probability histogram. Again, you might want to pause the video so that you can copy this stuff down. Next, let's answer the other questions we were asked in this example. We were asked, what is the probability that at most one person in the sample has blood type O negative? In other words, we're asked, what is the probability that X is at most 1? Now that's the same thing as saying the probability that X is 0 or 1. So at most 1 means you could be anything up to 1, including 1. To answer this question, I'd like us to recall that in a discrete probability distribution, we make the histogram by taking the probability and using that as the height of each rectangle. However, because the width of each rectangle is 1, the height is actually equal to the area. So we can get the probabilities by looking at areas. And I've labeled the heights / areas / probabilities above each of our histogram bars in this diagram. So we have area equals 0.78 for the first one. That's when X equals 0. We have area 0.225 for when X equals 1. So that gives us the probability also. We have area 0.025 for the probability that X equals 2. We have probability 0.001 that X equals 3, and that gives us the area of that teeny tiny rectangle there. And our last rectangle had probability approximately 0, so that's the area of that one. So how are we going to get the probability that X equals 0 or 1? Well, we're going to take the total area that corresponds to those two X values. So we're going to take the total area of these two rectangles. In other words, we're going to add 0.748 to 0.225, which gives us 0.973, or approximately 97.3%. The last question we were asked was the probability that at least 2 people in the sample have blood type O negative. So that's the probability that X is at least 2, meaning the probability that X is 2 or 3 or 4. And again, we're going to get this by adding up the areas. So we're going to add up the area of the last 3 rectangles. So we'll add 0.025, 0.001, and our 0.000. And that gives us 0.026, or about 2.6%. Let's end this video with a Build Your Understanding problem. You're given a binomial probability experiment and asked to compute the probability that x equals 2. Notice that it's not asking you for the entire probability distribution. That means you don't have to calculate the probability of any x values other than x equals 2. And similarly, it's not asking you for a histogram, so you don't need to give the histogram. Let's see, I guess I should give you a hint here. It says a student guesses randomly on 8 multiple choice questions, each of which has 5 possible answers. So each question is a trial. And on each question, he's got 5 answer choices. So one question is one trial. Now, we need the probability of success in any one trial. So if he has 5 choices, one of which is correct, let's say for the sake of argument that C is correct in this problem, but he's guessing randomly. So what's his probability of success? Hopefully you can see that that's going to be 1/5 or 0.2. Okay, that said, I'll leave you to work through this and we'll go through it at the beginning of the next video. Good luck.